Howdy, howdy, howdy. We're on assignment 6. We're going to mark this bad boy. Let's do it. Okay, so remember, as you're marking, I know you know this, but I'm going to say it anyways. As you're marking, please don't just say, yeah, I did good, or no, I did bad, right? That's not good enough. That's not why we mark. We're here to learn from our mistakes. So just marking yes or no is not good enough. Please make sure with your pen, you are writing down your corrections. And that way, when you go back to review this, you can see where you made your mistake. And even better, how to fix it, because that'll be written in pen. So make sure you are following this and you're making your corrections as we go. Anyhow, let's do this. Question 1A. Well, it should just be 1. Pardon me. I'll fix that for yours. Sorry. Choose one type of fraction block: 1/6, 1/3, or 1/2, or 1 whole. And we're going to take 6 of that type, trace them below, what fraction they represent. How do you know it has to be greater than 1 whole? Holy smokes, that's a lot of questions, Mr. Lewis. Well, let's go to, I'm going to go to Mathagon just because I don't want to draw here. That'll drive you nuts. Let's go ahead and draw them. So I'm going to do all of those fractions for you just in case you chose one, okay, or the other. So here's, what was it? Pardon me. 1/3 and 1/2. Very cool. Okay, so 1/3, 1/2. You may have noticed that these fractions are in ascending order because it's getting bigger, smallest all the way to the biggest. Anyhow, it doesn't matter. Let's do this thing. So 1/6, I know these little triangles are 1/6. So they want me to have 6 of them, right? So let's go ahead and make 6 of them. Put it together. There we go. Oops. Cool. Copy, paste. I'll flip this upside down. Okay, cool. So there's 6. 6/6. What fraction does that make? 6/6. Cool. Or in other words, check it out. 1 whole. Neat. Okay, well, that's equivalent, isn't it? Awesome. We'll sit on that for now. Okay, let's go to 1/3. We know that the rhombuses or the diamonds, they are 1/3, and they want us to have 6 of them, right? So let's make a whole bunch here. Yikes. Sorry, I'm struggling here. There we go. Boom. Flip that around. Awesome. Okay, there's 3. I need another 6. I'll click copy and paste. Awesome. So there's 6 of those guys. And what fraction, what new fraction is that? Well, I know it's still thirds because each of these are thirds, right? How many thirds do I have? Well, 3, 4, 5, 6. 6 thirds. Neato. All right. And also check that out. That is equivalent not just to 1 whole. Boom. But to 2 wholes. Boom. Cool. So 6 thirds is equivalent to 2 wholes, which also makes sense because we know that fractions are just division questions. 6 divided by 3. Oh yeah, you betcha that equals 2. Cool. It's all coming together. Okay, we're talking halves. Okay, and they wanted us to have 6 of those bad boys. So let's go ahead with that. 1, 2, 3, 4, 5, 6. Deadly. Cool. There you go. And what fraction does that make? Well, I know I'm still talking about halves. So my denominator is still the same. But how many do I have? I have 6. Yep. And you're probably already screaming at your computer. Don't say it, Lewis. Don't say it. I know what that's equivalent to. Well, I'm going to show you anyway. Check it out. 6 halves is equivalent to 3 wholes. Neato. Kind of cool. And again, division, 6 divided by 2 is 3. Kind of cool. Okay, and the very last one, now finally, we're just talking about wholes. And they want 6 of them. Well, I'm just going to copy that. Boom. And we've got 6 wholes. What fraction does that look like? Well, wholes have 1 as a denominator, and I've got 6 of them. 6 wholes. Or you could have also said 6, because 6 divided by 1 is 6. Kind of neato. Cool. So you could have chosen any one of those fractions to answer question 1. Okay. What fraction they represent? We did that. How do you know each of these have to be greater than 1 whole? Well, if I look at these fractions, so 6/6, 6 thirds, 6 halves, 6 wholes, all of these have a numerator that is greater than the denominator. Oof. Okay, except for 6/6. 6, 6, the numerator and the denominator are the same. And whenever that happens, you know that that's just equal to 1 whole. If I could have 17 17ths, and that's going to be equal to 1 whole, because I can reduce it by a common factor. And of course, 17 and 17 can both be divided by 17, and that equals 1 whole. I can also look at it like a division question, right? 17 divided by 17, yeah, that's going to be 1. So whenever your numerator is the same as your denominator, that's equal to 1 whole. But all these other fractions, 6/3, 6 halves, and 6 wholes, we know that they have to be greater than 1 whole, at least greater than 1 whole, because the numerator is bigger than the denominator. For instance, one more example for you. Let's do halves, sure. Okay, and let's say the improper fraction they give us is 3 halves. It's improper because the numerator is bigger than the denominator. Cool. Well, I need to have 3 halves. So right now I've only got 2 halves, and now I've got 3. Okay. Well, notice we've made a whole, right? Because all I needed to make a whole out of halves is 2 of them. But I've got 3. So whenever your numerator is bigger than your denominator, it has to be greater than 1. It has to. Cool. So there's your answer for question 1. Question 2, excuse me. What fraction does each represent? Use proper or improper fractions in your answer. Well, I see 1, 2, 3, 4, 5, 6 parts. 3 of them are shaded in. If I really wanted to be spicy, I could reduce that to 1/2. Divide both by 3. Gets me to 1/2. That's just good fun. Okay, now these ones can be tricky. And a mistake that a lot of us make, or rather that I've seen, maybe you guys didn't, that'd be great, but if you did, that's okay, is a lot of people will say, okay, I know the denominator is how many there are total. So they go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and they put 12 as the denominator. But this is actually wrong. What we need to count is, yes, the total, but only the total in 1 whole. So that's 5, 6. We've got 6 total in 1 whole. So that has to be your denominator. Your numerator is how many are shaded in. So 6, 7, 8, 9, 10. 10 sixths is my improper fraction here. Same thing here. I could count all these and have a new denominator of 18, but no, that's wrong. How many total in 1 whole? There is 4, 5, 6 in 1 whole. How many shaded in? Well, 6. I see 12 now, 18. So 18 sixths. You could also just say this is equal to 3 wholes, because I see 1, 2, 3 wholes, which of course is just equal to 3. Cool. Over here, yep, you already got it. 6 parts total in 1 whole. How many in my numerator? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 sixths. Awesome. Moving on. Number 3, Kenny used pattern blocks to represent 10/3. How do you think Kenny knew to use the 10 blue blocks? So these blue blocks like this. How would Kenny know to use those blue blocks? Well, because blue blocks represent thirds, right? Thirds on that denominator, and that's what 10/3 has here. So if you said anything like, well, Kenny knows the blue blocks are thirds, good for you. That's the correct answer. B, if he used green blocks, how many would he have needed to represent the same value as the 10 blue blocks? Well, let's go back to Mathagon here. Okay, and I've got a real big mess here. I'll scroll down. Okay, so they want 10/3. I'm going to pause it while I build that. And presto, boom, there it is. I'm talking thirds because it takes 3 parts to make 1 whole. And how many do I have total? Well, 3, 6, 9, 10. 10/3. Very cool. Now, the question said how many of the green sixths would I need to make this equivalent value? Okay, well, the triangles here are not green. I'll make them green really quick. Cool. Okay, I'm going to pause it while I do that. But before I do, just remember, to make an equivalent value, I'm going to prove that it's equivalent by showing that it takes up the same amount of space. So that's how I'm going to be doing that. Okay, so I'll pause it. So boom, I'm not done yet, but I've made 1 whole out of the 6th. Okay, we can see that that matches up with that hole there. So I'll just copy, paste that. Cool, so that guy's taken care of. Paste this, boom. So that guy's taken care of. And I'll do it one more time, but got to make some deletions here. Cool. And this guy, yeah, definitely fits over top of that. Cool. So now let's make my improper fraction. Well, I know I'm dealing with 6 parts total in one hole. So 6. Okay. And how many total? Well, 6, 12, 18, 19, 20. 26. Now look at the relationship between these numbers. I think this is kind of cool. We know that thirds are twice the size of our sixths. And we can prove that, right? Because it takes 2 sixths to fit inside each third. So it should make sense that our numerators just doubled, right? Because for every 1/3, there's 2 sixths. So essentially what we did was we just drew a line, or we could even just cut these guys, just like this. Boom, check it out. Now it's exactly the same. Kind of neat. Okay, I can do the same thing right here with all of them if I really wanted to, making these into sixths. Cool. Okay, but I won't. Anyway, there's the answer to that question. Let's move on. Question 4, it says, use pattern blocks to model each improper fraction. Trace over the shapes to make each fraction. So I don't want you guys drawing these because it's kind of hard. Use the actual blocks you have in your desks to trace. Okay, that's what you should have done. So they want 14/3. Holy smokes. So I better get back to Polypad. Okay, I've already got 10 right here. So I'll just copy, paste. Cool. So 3, 6, 9, 12, 13. I just need one more. Awesome. Okay, so there you have it. 14/3. That's what that one should look like on your page. Okay. Next one, 4/3. Well, that one's a lot easier. Like that. I'll do that right down here. Okay. So I'm still talking thirds. So that's my denominator. And I've got 3, 4. 4 of them. Perfect. Moving on. 11/6. Okay, well, I'm already pretty darn close to that with this one here. So I've got 6, 12. I'll delete everything else here. Because all I needed was 11, right? Yep, 11/6. I'll delete one of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There you have it. 11/6. Okay, and the very last one here, 3/2. 1, 2, 3. Now, this is 3/2, and I absolutely could build it like this. But if you can put your blocks together and form a whole, you should, because that helps us just visually understand that this is an improper fraction. It's greater than one whole. So this is how you should draw it. Okay, definitely making sure your blocks are still making wholes when they do. Okay, awesome. So there you have it for number 4. Question 5, it says n/3. Oh my goodness, letters. Okay, the letter is a variable, and that means it could be any number. It's an unknown. That's why it's called a variable. Its value varies. It could be 1, it could be 10, it could be 1,000,000. Doesn't that? We don't know. Okay, so anyway, the fraction n/3 is greater than 1. What do you know about the numerator? Well, if we're talking about thirds, we're using these beautiful blue blocks yet again. Okay. And they said n/3. So that could be absolutely anything. Well, let's have a look at 1. So that's 1/3. We can see that it's not making a whole number yet. What about 2? Yeah, you guessed it. That's not a whole number yet. Okay, it's still just a proper fraction. Even 3/3. Looks like that. Okay, cool. That's finally a whole number. Okay. But still, though, it says the fraction n/3 is greater than 1. It's greater than 1. So 3/3 doesn't work either because that's just equivalent to 1 whole. That's just still 1. So at the very least, this has to be 4/3. Has to be. Would 5/3 work? Absolutely. Would 6? Would 7? Would 8? Any of those numbers would work as long as our numerator is greater than our denominator. And that's what your answer should say. My numerator has to be greater than 3 if this fraction is going to be greater than 1. Okay, next question, very similar, except this time the fraction 4 over n is greater than 1. So our denominator is the unknown value. What do you know about the denominator? Well, again, this 4 over whatever has to be greater than 1. Okay, so if I said 4 over, I don't know, well, let's try 4. Okay, well, that's just 4/4. And that's going to look like this. Oh, let's cut this up, make it into fourths. Sorry, this is not a very good job. Okay, pretend those are even. Okay, so there you have it, 4/4 right there. Okay, that's still just one whole. It's not greater than one whole. It's equal to one whole, so it can't be 4/4. Okay, well, what about 3/4? It would look like this. Well, that's even less. That's definitely less than one whole. Okay. Oh, geez, and you know what? I should be monkeying around with the denominator anyhow. Pardon me. Okay. What if we had, oh, I don't know, 4/6? Okay, well, we said these are sixths. That would look like this. Boom. Okay, definitely less than a whole. So you're probably screaming at your computer, Mr. Lewis, your denominator has to be less than 4. Because this ensures that this improper fraction is greater than one whole. And again, we can show that visually, just like this. Maybe, holy smokes. Here we go. There. Okay, so there's 3/3, 4/3, boom. Okay, I could also have said, hey, 4/2. So there's 3/2, 4/2. Yep, there you go. That's definitely greater than one whole. That's 2 wholes. And lastly, but not least, I could have said 4 wholes, which of course is just 1, 2, 3, 4 wholes. There they are. Okay. So anyway, for this question, your answer should have said n has to equal less than 4. Or you could have said n is equal to 3, 2, or 1. Because that lower denominator than our numerator ensures it's greater than 1. And that's it. Thank you for following along. Thank you for correcting any mistakes you may have had. Now you've got some beautiful study material. Good luck and have fun.